Greetings, everybody. This is Dr. Gomez. This video will hopefully take you through the steps you need to do the first online lab on Vector Addition. And I've got the instructions here. And what you're going to do is this lab, you're going to add two vectors. We'll call them A and B. And the sum, which we call the resultant vector R, is A plus B. And remember, this involves some right triangle trigonometry, because both vector A and vector B will have x and y components, and hence the resultant will have an x and y component. And vectors A and B will make a certain angle with the horizontal, while the resultant vector will make an angle with the horizontal. And we want to, and the resultant vector will have a magnitude as A and B have magnitudes. And so what you're going to do is I've set up an Excel template, and see here it says online lab number 1 vector addition template. And what you'll want to do, and so here's the template, and you'll want to put your name on it. And what you'll do is as you're running the simulation, you're going to fill out the template, and I'll create a Dropbox on the Georgia page, and you'll submit the template through the Dropbox. And so we'll get to the link to the simulation in just a second, but notice column B, that's the vector A. Column C, that's theta A, the angle of vector A. Then column F, see here, column F is vector B. Column G is theta B, the angle of vector B. And then notice you have here the AX, the X component of A, AY, the Y component. Likewise for B, column H, BX, column I, BY. Then column J, RX, column K, RY. Then column L is the magnitude of the resultant, which you're going to calculate. Then notice here in column M, that's R sim, meaning the resultant from the simulation. Then here, theta, that's the theta that you'll calculate. Then see in the next column O, that's theta sim, meaning the angle from the simulation. And then you're going to do the percent difference between R and R sim, meaning the calculated R and the simulation R, and the percent difference between theta and theta sim, meaning the calculated angle and the angle that the simulation gives you. And notice I've for the first for the first 6 vectors, I've given you A and theta A, and I've given you B and theta B. And then for the last vector, you can choose your A and B. The only qualifying being that down here, A and B cannot be parallel, and then they cannot be perpendicular. Those are the 2 trivial cases. But for the last choice, you can choose any vector A in any angle. Again, as long as they're not, A and B are not parallel and they're not perpendicular. So let's look at, so what you're going to do, here's the link to the simulation. So we're going to open the simulation, and I'll run you through the first one, and that should give you an idea of how to do it. So we're going to open up the simulation, and here it is, and you click play, and then let's go to lab. And here's your grid, here are your 2 vectors, and we're going to do, we want to do values, and we want to do angles. We'll click that. Now let's go back to the template. I want, for the first one, I want vector A to be at a magnitude of 30 and at an angle of 0. And I want vector B to be a magnitude of 24.4 and an angle of 55. So let me do A first. Let me set up A to be at magnitude of 30, angle of 0. So I'm going to go to the simulation. And here's the blue my vector. I'm going to drag it over here. I want the angle to be 0. So it's going to be along the x-axis. And I said the magnitude is 30. And you can see up here in this bar right here, my vector A is at a magnitude of 30 and the angle is 0. Okay. Now I want vector B to be a magnitude of 24.4 at an angle of 55. So let me go ahead and do that. 24.4 and an angle of 55. And remember, you're gonna start. You put vector B, this orange one, you put the tail of vector B at the tip of vector A. And now I want the magnitude to be 24.4 and the angle to be 55. And right there, see my vector B. See, magnitude 24.4, see the angle here, angle of 55. And the way you always do that is the blue would be vector A, the orange, tannish orange here, that's vector B. The tail of vector B will be at the tip of vector A. Then I'll use this one. Now I want to put in my resultant. And the resultant goes from the tail of A to the tip of B. You can go ahead and take this vector and drag it and right a little bit a little bit tedious, but not too bad. There. I'm having a little trouble with my mouse here. There. Let me pause this for a second while I get that vector straight. Yeah, so now I've put my resultant. And according to the simulation, the magnitude of the resultant is 48.3. You can see it here. And if you can't read the angle, you know, it's listed in this chart. The angle of the resultant is 24.4. So let me go ahead and put those into the simulation. I know the magnitude. So this is my R vector. The fact that the simulation says V, don't worry about that. That's my resultant. So its magnitude is 48.3. Oops, daisy. That's the simulation, 48.3. And the angle of the simulation was 24.4 degrees. Oops. Right there, 24.4. And notice I've had it set up so they're in blue. Now notice the percent difference column it will begin to update itself because I entered the formulas for you because percent difference is very trivial. But now we need to calculate first AX and AY, then BX and BY, then RX and RY, and then R and theta. Okay. So how do we calculate AX? Well, remember AX is a magnitude of A times the cosine of theta A. So what you'll do is in this column, where in that cell, you type in equals. Remember now we got to think in terms of Excel language. Equals. Well, the magnitude of A, it's 30. It's in cell B8. So we do equals, and then we do B8, and notice the cell B8 is highlighted. And so it's B8, and then it's times, which is the asterisk symbol, times. And remember, it's cosine of the angle. So it's cosine. And theta A, that's C. So it's C8. So it's cosine C8. But we need to convert the angle in Excel when it does calculations involving angles. The angle needs to be in radians. So cell C8, that's theta A. Well, I need to convert it to radians. So I have to do times pi. So C8, then asterisk. The Excel function for pi is a pi, and then a empty left and right parenthesis. So that's C8, so that's times pi, then divide by 180. Divided by 180. And then close, make sure your parentheses are matched up. Closed. And now I can hit check. My mouse is a little bit acting up a little bit. There. And obviously, the magnitude of AX is going to be 30 because of the way we've chosen the vector A. Well, AY is the same thing, only instead of cosine, it's sine. So let me go ahead and just, let me just go ahead and take this formula. I'll just type it again. It's good practice. It's going to be equals. And you want to use this, be generous with your spaces so it's easy to follow. Again, it's going to be B8. That's my cat. Ignore that. B8 times, which is the asterisk. Then now just instead of cosine, it's going to be sine. So it's going to be sine. And again, the angle theta A is column C. It's going to be C8 times, we have to remember to do pi, empty parentheses, then divided by 180. And then make sure you close the parentheses. Then hit check. And of course the y component should be 0. Now let's go ahead and let's calculate the x and y components of b. Well, the same thing. What is the x component? Equals, space, it's cosine. It's b cosine. Well, remember, b is in cell F8. So it's going to be F8 times cosine. Now the angle theta b is g. So it's going to be cosine G8. And then we want to convert. So it's going to be times pi, left, right parentheses, divided by 180. Make sure parentheses are closed. Hit check. And what happened? I accidentally hit delete. Let me pause this for a second. Okay, so now here for bx, right there, I've entered the formula. It's F8, because F8, that's the magnitude of b. Cosine of G8, G8 is theta b, then times pi over 180, because again, I have to convert to radians. So I get bx is 13.995. Now I have to do the same for by. By is equal to, again, equals F8. Now remember, it's sine, so times the sine of G8, then times pi, left, right parentheses, divided by 180, close parentheses, hit check. There. So I've got bx and by. Calculate. Now, how do I get rx? Well, remember, rx is going to be ax plus bx. So now here in the cell for rx, this blank cell, you type in equals. And I like parentheses, a couple of spaces, left parenthesis. Now, ax is d8. See, and notice D8 is highlighted. Then space plus space, D8 plus H8. Close parentheses. Hit the check. Yep, looks right. Now, what is RY? Well, RY is AY plus BY. So again, in this column, equals. I like spaces, parentheses. Okay, AY is E8. Then plus BY is I8. I8. And then hit check. There we go. Now notice now the theta automatically updated itself because I entered the formula for theta for you. Remember, theta would be the arctan of Ry over Rx. So it's going to be the arctan of K8 over J8 here in the formula bar. But then now to, again, degrees, I have to do times 180 over pi. So I enter that formula in for you. And let me go ahead and let me make this column blue. There. Okay, now notice the theta sim the percent difference between theta and theta sim automatically updated itself. Okay, now I need to calculate the magnitude of R. This is the L column, and compare it to the simulation R. Well, remember, what is the magnitude of R? It's the Pythagorean theorem. So, equals space, it's the square root of Rx squared plus Ry squared. So do equals, parenthesis, and then Rx is J8, so it's going to be another parentheses, J8, close parentheses, the caret symbol, and then 2. That's Rx squared, space, plus, space, parenthesis, Ry squared, which is K8. So, K8 squared, and then a space, and make sure you close off all your parentheses. Then let me hit check. And I messed up somewhere. What did I do here? It's square root. I forgot the square root. See, on the very outside of the parentheses, I need SQRT at square root. And then there we go. That's the square root of Rx squared plus Ry squared. There we go. And now notice the percent difference. So then you're done. So what you'll do is then in the next step, you're doing the same thing. I'll now make A to be a magnitude of 14.1 at an angle of 45. And now the nice thing is with Excel, you don't have to retype these formulas. You can go ahead and just copy them down. So notice here, I'm going to, let me click outside. So let me click here, let me drag over, and now see, you can go ahead and just, when you see this little crosshair, just drag down and so you can and likewise here you can do, that's my cat, I know it's a little rescue cat and he's in the crate right now. And then likewise here you can take these formulas, go all the way, then when you see the little square, oh wait a minute, I have to undo that. I made a little bit of a mistake. Let me see here. Then here, and you can do them one at a time. You might want to do this. That's the B's. Then here's my oops. Then but you can copy them all down like that. And likewise here. That's the beauty of Excel because it automatically updates the cell references. And then you can even do with the angle. You can go ahead and copy that formula down. Because notice here, notice in the formula, it doesn't matter. Notice in this one, notice the cells are K8 and J8. Then when you go down to the next one, it's going to be K9 and J9. See that? And see, that's the beauty of Excel. And you can see it automatically updates. So, so now all you have to do, now you just have to go ahead and get the... Now in the future, I'll have you enter the formulas yourself. But I thought for this first time, so let me go ahead and... There. So so that's the template. So you're good to go. Oh, here we can delete this. And like I said, you're just doing the same thing 1, 2, 3, 4, 5, 6, 7 times. And it's just to give you just a good introduction into vectors. And like I said, for the very last one, you can choose any A and any B you want, other than they can't be parallel or perpendicular. Alrighty, let me go ahead and get this video saved and get it posted.